All right. Well, welcome back. And what we have here is we're going to be using the first derivative test. Now, if you're wondering what the first derivative test allows us to do, well, the first derivative test allows us to identify where we have local extrema, or AKA max and minimum values. All right, and we're looking for the location of these max and mins, and we can obviously identify what they are as well. But we're looking for the location of the local extremum. Now, to do this, a lot of students say, well, how do we do this? Well, I don't start with the how. I actually go through the why and where of how we're going to look for these. Now, according to the first derivative, we identify local extremum. All right. So in this case, g of x, all right, has a local max at fill in the blank. I don't know where that is yet. At blah. All right, because here's a justification you can use. Because we know that that will occur when g prime, the first derivative, what happens with the first derivative is that it needs to change from, must change, g prime changes from a positive value to a negative value. So we're looking for where g prime changes from positive to negative. That's what the first derivative states. If g prime changes, or the derivative changes from positive to negative, we will have a local max, all right, at that point. Now, we can also find where g prime, or sorry, g of x has a local min. Because that occurs, so g has a local min at, fill in the blank, blah, because in this case, g prime will change from negative to positive. Okay, from negative to positive. So that is what we're looking for. That is the first derivative. That essentially is what will allow us to find the local extremum. This will always be the case no matter what you do. We're always looking for where g prime changes from positive to negative and when g prime changes from negative to positive, both from max and then a minimum respectively. Now that happens because you have to think g prime is the slopes. And when g prime is positive, that means the slopes are positive on the g graph, which means they're increasing, and then changes to decreasing when they're negative. And then vice versa for the other one. All right, so we're looking for when g goes from increasing to decreasing and from decreasing to increasing for the minimum. So now how do we do that? Well, in order to figure out this change, all right, in the derivative, I guess we have to figure out where the derivatives start to change. So the first step in order to figure this out is that we need to find g prime's critical points. So over here, we're going to find where g prime equals 0, or where g prime does not exist. So we're finding the critical numbers. All right, find critical, all right, numbers. Okay, so we're going to do that. All right, g prime of x, we got the 127, we'll just stick that out there. We have 4x to the third plus 12x squared, and that is our critical value. We're going to set it equal to 0 because it's a polynomial, all right? And we're going to factor out some things. I can factor out a 4. I'll factor out 4x squared, and I'll have the 27 still up there. And what I have left inside, it appears to be x, and then I got a 3. So where does g prime equal 0? Well, g prime equals 0 and appears to be at 0 and negative 3. Okay, well, that is where my critical points are. That's where a change in the derivative will occur. If you remember from pre-calculus, wherever a graph changes from positive to negative, that's at a 0. And so that's where we find our zeros, our critical values. So from here, we need to test our values. Now, in doing this, I'm going to use a sign chart. The sign chart will allow me to test to see where these values change. So I'm going to put in negative 3 here, 0 here. We're going to test the interval from negative infinity to negative 3, and negative 3 to 0, and 0 to infinity. I'm going to use g prime. Make sure you label your sign chart correctly, because we are using g. And we're going to test it out by using this. So I'm going to plug in a negative 4. So if I plug in negative 4 into my derivative, g prime, what do I get is a positive value, and then a negative value. So positive times a negative is going to give me, oops, negative 1, just a negative value, so I only care about its value. I get a negative answer, which means that G is decreasing on this interval. Over here, I'm going to plug in a value like -1, something easy. If I plug in -1, once again, I'll have a positive value. I plug in -1, I'll get another positive value. And so what I have is positive, positive, which makes G prime positive, which makes G increasing on that interval. I plug in a 1, and over here I plug in a 1, and I get a positive value. And I get another positive value. So once again, I have, all right, a positive, oh, that's interesting. All right, and that's going to be increasing. And so looking at here, where do I have my local extremum? Well, according to our analysis, we're going to check this out. It appears I only have one here at -2 positive, which would make that a decreasing, increasing, make this a min. Right here, we're going from increasing, increasing, so this is really nothing. There's none, it's just a horizontal tangent appears. So really, when we fill out this, where do we have our local max min? Well, we only have a local min at -3. So up here, x equaling -3, all right, is where my local minimum will be. My local max, I don't have any. G of x does not, let's say does not have a local maximum. All right, take that out. And what we have then, because G prime does not change from positive to negative anywhere on the graph, all right, on the interval. So, well, let's check this out. All right. So let's check this out on our grapher. I'm going to actually take out my graphing calculator because I always get very interested in graphs like this. I'm going to go y equals. Let's clear that. I'm going to go and plug in, all right, 1 divided by divided by 27. And we have x to the 4th plus 4 x to the 3rd. I apologize for the stuff in the background. Very busy day here at Wisconsin High School. And we graph this. Hopefully this will work. Well, look at our graph. I'm going to take this and see if this matches what we thought. Well, actually it does. If you look at this, we actually have right here, it appears to be a local min. Actually, it's an absolute min according to our graph. Local min at, well, I didn't know, well, it's at x equaling -3. Just like we found. This one point, well, what's happening right here at 0? Well, at x equaling 0, we realize that there is a horizontal tangent. But it doesn't change sign, so it just keeps on increasing. So it is not a max or a min. It is nothing. It's just a horizontal tangent. So we affirmed, according to our graph and through our analysis, that yes, g of x has a local min at x equals -3 because g prime changed from negative to positive. But it does not. All right, I repeat, it does not have a local max because g does not change from positive to negative anywhere on that interval. All right, well, that is using the first derivative test. Once again, it helps us find local extremum, and I hope you enjoy. All right, look.